Hello everyone, welcome to the Mathematics in my channel. In this video, we are going to prove this nice integral formula. Integral from 0 to infinity f of m square x square plus n square over x square times dx is equal to 1 over m. Integral from 0 to infinity f of x square plus 2 times mn dx, and here m and n greater than to 0. Then using this integral formula, we are going to evaluate integral from 0 to infinity sine of a square x square plus b square over x square dx. Okay, how to begin? Well, first this integral I am going to take I. So I is equal to integral from 0 to infinity f of m square x square plus n square over x square dx. Then I'm going to take a substitution. X is equal to n over m times u. Then we can differentiate. Dx is equal to here we have minus n over m times u square du. Okay, then we can plug in. Now we should change the boundary when lower limit x approaches to 0. We know u approaches to infinity, x approaches to infinity, u approaches to 0. Then f of here m square times x square, we know n square over m square times u square plus here n square over x square, we know again n square times m square u square times dx, we know minus n over m times u square du. Okay, then we can simplify here limit. Now we can write 0 to infinity. When we change the boundary, we know this minus sign get cancelled, and here we know m square get cancelled, and here we have n square get cancelled. So we have f of, now I'm going to write m square u square first. At the same time, we can change the variable because we know the definite integral independent of the variable. So instead of u, we can plug in x. So we have m square x square plus here again n square over x square times, here we have n over m times x square dx. Okay, then here this is also equal to I, and here this is I. So I'm going to take sum of these integrals. So we have 2 times I is equal to, now same boundary, we know this function is a common factor. So f of m square x square plus n square over x square times 1 plus n over m times x square dx. Okay, then this part we can express as a perfect square. So we can write here integral from 0 to infinity f of now here we have mx minus n over x perfect square. We know middle term 2 times mn, so here plus 2 times mn, then here 1 plus n over m times x square dx. Okay, then here we have m, so I'm going to take 1 over m as a common factor. So 0 to infinity f of mx minus n over x perfect square plus 2 times mn, then here we have m plus n over x square dx. Okay, then again I'm going to take a substitution. Here we have mx minus n over x, so I'm going to take mx minus n over x is equal to t. Then if we differentiate, m plus n over x square dx is equal to dt. So we can plug in. Also we should change the boundary. So here 1 over m. Now when x approaches to 0, we know t approaches to minus infinity. Here again infinity f of now mx minus nx, we know t, so t square plus 2 times mn, then m plus n over x square dx, we have dt. So here we have dt. Then we know this is equal to 2 times I. Now we know I is equal to 1 over 2 times m, integral from minus infinity to infinity. Here now f of, now we can change the variable, x square plus 2 times mn times dx. Now this function, if this function is an even function, we can write here 1 over 2 times m times 2 times integral from 0 to infinity f of x square plus 2 times mn dx. So we know these two get cancelled. So we have 1 over m integral from 0 to infinity f of x square plus 2 times mn times dx. Okay, we are done. This is the right hand side of our integral formula. Okay, then we have to evaluate integral from 0 to infinity sine of a square x square plus b square over x square dx. And we know here a and b greater than to 0. So we can apply our integral formula. So we can write according to this formula. Here we have now m, we know a, so 1 over a, integral from 0 to infinity, we know this is an even function. Here now we have f of x square plus 2 times mn, so sine of x square plus 2 times ab dx. Then using trigonometric formula, we can express sine of x square plus 2ab like sine of x square cosine of 2 times ab plus cosine of x square sine of 2ab times dx. Now here cosine of 2ab constant, sine of 2ab constant, so we can take outside of the integral sign. So cosine of 2ab over a, integral from 0 to infinity sine of x square dx plus sine of 2 times ab over a, integral from 0 to infinity cosine of x square dx. Okay, in the previous video we evaluate these integrals, we know Fresnel integrals. So we can write here cosine of 2ab over a times, this is equal to square root of pi over 2 times square root of 2 plus, now here we have sine of 2ab over a times square root of pi over 2 times square root of 2. Now we know we can take square root of pi over 2 times a as a common factor. Then here we have cosine of 2ab times 1 over square root of 2, we can write sine of pi over 4. Then here plus sine of 2 times ab, 1 over square root of 2, we know cosine of pi over 4. Now again using trigonometric formula, we can write pi over 2 times a, and this is equal to sine of 2ab plus pi over 4. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.